Hi everyone, I'm Chaitanya. Thanks for joining in. Uh, I work as principal data scientist at Allen, and let me introduce myself. And I have roughly 15 years of experience working mostly in areas like search and relevance in domains like ads and e-commerce. My previous stints were in say chronological order. Uh, I initially was working on fraud detection kind of areas in Amazon, and then for roughly 5 years after that, I worked at Microsoft on Bing ads, where I worked on text ads, product ads, and so on. And after that, I've joined Flipkart, where I worked on uh, search, e-commerce search as well. And after that, I was at Twitter for roughly a year, working on ads again. And roughly 11 months back, I've joined Allen as their first data scientist and principal data scientist here. And last 1 year has been an interesting ride. And basically, what interested me in joining Allen as well is the impact that we could create, right? So basically, education is an area that I've been passionate about, and basically, uh, the pure impact that if you can create, if you can say, uh, make students understand the their curriculum, right, as quickly as possible, and give them back time. That is something that I've been passionate about, and that's what brought me to Allen. So yeah, so we can actually go into the presentation, and then we'll start by introducing. Yeah, we'll this is the agenda for today. We'll introduce who we are, and the challenges of actually trying to do personalization of education at scale, and why we want to do it, and what we have done till now, and the future directions, and then we'll open it up for questions. So for those of you who don't know about Allen, we have a legacy of roughly 3 decades, and in mostly the test prep space, where we are the leaders in NEET and JE preparation. And recently, about a year and a half or so back, we have started this Allen Digital, which is the digital wing of Allen, to with visionary leadership under industry pioneers. And basically, the main goal, uh, especially for the data science part of digital, is to personalize learning, and basically scale that one-on-one attention, right? So as if a tutor is available with every student, each of the lakhs of students that we have all the time. That is the goal, and with an accessibility mission, right? So that education is available to everyone in all, say, a tier 3 city or something also. And another interesting thing that is that about Allen is basically we want to merge tradition with technology. Basically, the traditional approach of having our star teachers deliver the best way of teaching a particular subject, along with the technology part, which will solve the rest of the things after the student has gone through the lecture, whether they have understood anything, each part of the thing, and then uh, basically diagnosing what the students' weak areas are, and then trying to fix it. That is a killer combo, in my opinion. Which is the second part is where the digital would come in, as well as in the first part, where we want to scale it to in an accessible way. That is where the live lecture kind of a product comes into picture. So I want to start by thinking from a student perspective, because student is at the center of what we do, and in the mind of a student, right? So there are multiple things that are going on, and in the classroom, right? So uh, it could be that. people feel that their basics are not right, and they are the student is not able to understand the current lecture because the basics are not right. This could be a problem. Or in the practice or revision, let's say I'm working on solving a particular problem as a student, and through while doing this I got stuck at a problem. Now I don't know what to do. Even in the offline setting, right, it takes a bit of time to actually go to the teacher or go to a doubt class and ask the question and then get it clarified. It's not instant in the sense that I got the doubt now, I want the answer right now. So that is also one of the things that the student might be feeling. And then in the test part, I don't know where I am, where I stand with respect to other students, and so on, because it is a competitive exam, and at the end what matters is where I am compared to others, right? So if there is, say, a tough topic, right? For example, is it tough for me only, or is it tough for everybody else? That also is sort of in this part. And then say it could be completely non-academic as well, right? So basically, how do I structure my study? How do I prioritize? Say I have some backlog like we discussed earlier in the classroom part, so I'm don't understand, say, let's say differentiation lecture is going on right now, and say my limits itself is weak, and I have to go back and refresh it. So that if I call that as a backlog, that backlog may keep increasing for a good number of students. So how do I prioritize between these, and how do I uh, manage time, and how do I structure my study time? If I have, say, a couple of hours to study every day, what should I study so that I'll maximize my chances of uh, getting a good score in, say, JE or NEET or whatever, right? So that itself could be an interesting problem for from the student's perspective, right? This is what the student faces. So, and there on the non-academic side of things, there could be other things like, say, memory retention. So I study these things and I forget very quickly. Maybe beyond 2 days, I don't remember anything. Or uh, I could have anxiety, in which case I study now. In the practice, I do well, but in the test, it seems like I can't recall the formulas, or the my memory fails me. So these all could be the set of problems that the student could be facing. And then how do we want to solve it? This is a framework that we uh, follow. It's not a heavy framework, as you can see. Basically, all this starts with is basically assessment and learning, and this cycle would help us actually identify the weak areas of the student, both curricular and non-curricular, academic and non-academic. And once we identify each weakness of the student, or this the first part is actually diagnosing all of these things effectively, and also in a way that is, say, non-intrusive, right? So say uh, for a bunch of these things, making the student solve more questions, especially in the areas where they are weak at, is sort of one way of assessing what uh, the student is weak at. So if we keep giving a lot of questions, especially in their tough or weak areas, then the student might get demotivated and not actually come back to the app or something, right? So diagnosing effectively with minimum overhead or minimum intrusion, that is one goal. And also infer basically diverse learning styles. So once we have, say, identified what the weakness of the student is, and we also need to know what is the best way to teach uh, a particular topic to this student. uh, and different students will have different learning styles and pace that they have, and somebody might prefer a short video, or and there could be different modes as well. So uh, we have to take that input from the student, that say I have an exam tomorrow and I'm preparing for that. So in that case, there is no point in actually deep diving into the topic and learning something new. Basically, what we want to do is run through and revise all the topics that I've already mastered, right? So those kind of things. And while doing all of this, let's say there is a there is a bot or something that could help the student while solving a problem, right? In the previous example that I have, let's say there is a teacher equivalent that we have built through a co-solving bot or something. In that case, what could happen is basically the student is solving together with the bot, and should how to maintain the privacy and security of the user data, right? So that also maintaining all of that, solving for the tough problems. This is uh, what the problem statement is for the data science team, and this is what we've been working on. And uh, we want to yeah, then showcase, go into what have we done till now, and what is the plan for the future, right? So in terms of major products, right, so we have three main products. One is the live classes, which would scale what our teachers are saying to all the students anywhere in the world through the app. And the second product is a doubt solving application, where the students can communicate through to the app through multiple ways. So uh, if, let's say, I'm working on my notebook and I'm solving a problem, I got stuck at some point, then if I want to ask what how to solve this problem, then I could just take a picture of the question that I'm trying to solve and ask it in the app, and I could get an instant solution. So just to build this, what kind of machine learning models and technology that we have to use is first understanding the notes part, right? So understanding images, and this is not just your run of the mill OCR, right, which just has text. The complication here is that we could have equations, say for example maths or physics equations, or sometimes chemistry equations, which have on top of the arrow there will be a catalyst and so on, and there could be benzene molecules, and there could be say circuit diagrams or something that could be there in the image. Without understanding that, you can't map to the right problem, right? So or in physics, say there could be a pulley problem where there could be different settings of pulleys, and the text would just read find x or find theta, right? So these so understanding OCR perfectly, uh, and understanding the equations and the steps that the student has done, this just the understanding image part is OCR. And apart from this, the student could also enter their conceptual question or something through text. And for the things that right now, all of those go to the teachers to solve. And we also have a product where, for a good number of problem solving questions, we can show a video solutions instantly, and that involves actually matching through a huge corpus of video solutions that we have, and seeing if this is exactly solving what the question uh, student asked, and trying to serve it to the user, right? So then this is not the level, this is what we are at currently, but this will not solve 100% of the problems or that the students ask, or anywhere close to 100%, right? So uh, to solve this, and also to interactively, let's say the student asked a question and we showed an instant match. So if there is a follow up, then what happens? It still has to go to the teacher and then get answered, right? So to solve even this part of things, where I can actually sit as if I'm sitting across a teacher, and try to solve my practice questions or homework or something. For that, we are actually building something called a digital buddy to interactively co-solve with the student. So, for example, in the earlier instant match example, the student could ask a follow-up question, and then the bot would answer based on grounding its knowledge to the video solution. And we are heavily uh, uh, relying on the corpus that we have, all the expertise that we have built over the last 3 decades of what we know, and all the material that we already have in the test prep space. We are using all of that to answer the question, so that whatever we show to the student is always accurate. So that is also one of the things which is exciting and very fulfilling while working here. And the next product, so we talked about live classes as the first product. Second one is the doubt solving part, and the third product is tests and personalized learning, right? So there basically this ties back to how do I structure my study time, kind of a problem that the student could be facing. And so there we have in the assessment and learning part, we have two things that we are working on. One is the adaptive practice, that is, say I just attended a lecture and I want to practice that topic, questions on that topic, right? So usually how it happens is I'd probably go through a few questions at the end of the chapter, or I probably practice previous year questions that occurred from this topic. But there it doesn't guarantee that the previous year questions or something would cover all the aspects of questions that could occur, that could be asked from this topic, right? All varieties of questions, all levels of difficulty, right? So basically that to solve that, and I want to do it in the fastest time possible, right? So remember our earlier uh, problem statement, that I want to do this as quickly as possible, so that whatever is my strength, let's say differentiation or maths is my strength, I quickly run through maths by solving minimum number of questions to still complete the mastery of that particular topic and get back time to, say, invest in my backlog or go play, right? So uh, that is where the adaptive practice is designed, where it will adaptively increase or decrease the difficulty of questions, and also make you go through all kinds of questions, so that the full all round questions that could be asked from a particular topic are practiced by the student given enough time. And using this, we can because this is assessment, we will also have a very good idea on what exactly is the strength and weakness of the student. And let's say if I can identify the weak area, I can show some learning content which could improve the student's weak area, right? So uh, in the personalized learning material part, so it actually helps if I can diagnose the weak area to the lowest level of granularity, right? So if I know that the whole of limits is a problem, then the solution is just showing the whole 1 hour video lecture, right? Which could be wasteful to the student also, because uh, from the student's perspective, uh, I already studied limits in the last year, say in the 10th class or something, and I feel like I know most of it. Why are you showing me a 1 hour video lecture, right? So basically, drilling it down to the lowest level of granularity actually makes sense, and that is what we try to diagnose at the lowest level of granularity possible. So, say at the level of application of L'Hopital's rule or something like that, that could be a level where we could be diagnosing, or even lower, right? So that is also something we are working on. And where what we've done till now is make sure we organize the content. So this is the third point, where we want to build a platform where all the content is properly organized in these in up to this level of concepts, or the most granular details that we want to teach, or uh, teach the student at, or diagnose the student's level at. And this after say organizing the content in something we call knowledge graph. We'll also talk about deep dive into each of these later on. uh, we also want different kinds of tags to uh, say provide useful reports to the student, right? Say if I'm making a lot of mistakes in questions that need a lot of memory, right? So say in biology or something where there is a lot of memorization needed. If most of my questions are not able to remember the exact terms or something, or maybe in a periodic table not remembering things is what I'm making mistakes on. We want to be able to say that to the student, right? So for that, one of the ways is to organize the questions that we have and tag them using this tag, saying, okay, this question tests most of memory, mostly memory or application or something like that, and then tag all questions using something like that. And then after that we can say aggregate all of this at the student's level and say, sure, your mathematical application seems to be wrong, or seems to be weak or something like that. So that is where the content management piece comes into picture, where we invest heavily into tagging, organizing. Sometimes when there is no content, generating content through LLMs, now that we have them available and in a reliable way. So uh, going into each of the products now, the first doubt solving part. So this is how our uh, UI kind of looks. So basically on the left side we have the ask a doubt part, which is from doubtnut, which is a Allen subsidiary. So there we can actually ask the question through a text or through the image. That's how the product currently looks like. And after the student has clicked a picture of their notebook, like you see on the right side of the picture, uh, you can see what the question is, and that we've detected the uh, topic and subject from the image. And as you can see, the text could be in Hinglish, which is Hindi written in English script. So uh, we can understand all of this. And so right now this is the multilingual, multimodal understanding of the students' doubt pictures is currently live. And shortly we'll be launching the digital buddy that I was talking about, where we would be interactively solving questions or problems with the student. And each of the step will be uh, grounded in the data that we already have, so that it is accurate at each step. And then the student can ask follow up, and still the follow up would be accurate and interactive, so that maximum value out of it could be uh, gotten by the student. So the idea is basically, if I get a doubt now, I should be able to get the solution immediately. So, and going into the digital buddy part, for example, can anybody guess how uh, easy or difficult it could be to answer, say, JE question paper using even GPT-4? Yeah, let's see. So this question is answered by a benchmark for people who are interested. So there is something called JE Bench, where people have tried to answer previous year JE question papers using GPT-4, along with some prompting techniques like chain of thought with self consistency. And then even then, the accuracy that they were able to come up with is around 38%. And this is the problem statement that we have with us, which is challenging, of course, but this is very interesting to solve. And what kind of uh, solutions we can come up with to improve the accuracy to a level where we can actually show students, right? So by the time we go to the students, we should have say very close to 100% accuracy, because we don't want to show anything wrong to our students, right? uh, if Because uh, the cost of learning and unlearning a wrong solution for the student is very high. So uh, basically we would want to show only the correct answers to the student as much as possible. And this hard part basically is solved by, as I think people who are familiar with LLMs might know, using RAG, we would have, like I said before as well, all the data and material that we've collected over the last 3 decades of mastering how to teach that 11th and 12th syllabus to students in our RAG, so that our answers are uh, uh, grounded on the best. best possible solution to each problem. And then of course prompting techniques like you see here, chain of thought and self consistency, even they got to uh, 38%, 39% kind of accuracy. So we have to obviously use even more advanced prompting techniques. And then tool use is one other another thing which is also being used and is very useful. Say if I have to calculate a value or a algebraic expression, right? So if I have to just multiply x plus 2 times x minus 3, that generating the answer to that is not in the problem statement of LLM, right? So it's a language model, it's trained to predict the next word, and it's not supposed to answer x plus 2 times x minus 3 or something exactly, because that is not its problem statement. So we want to outsource that to tools, and we do that, and those actually help. And we are also using agentic flows, and using all of this is where we have built these doubt answering uh, bots, which would be on the app shortly. And going to the next product, right, in the personalized pedagogy part, uh, we talked about assessment and learning, right? So in the assessment part, so yeah, so the adaptive test that I was talking about, so a student's problem statement could be, yeah, I have an exam tomorrow and 1 hour to study, 1 hour to practice, so just show me a set of questions so that I improve my marks, right? So again, the problem statement is that with by solving minimum number of questions, say again in this particular scenario, I should be able to maximize my score or maximize my recall on the whole syllabus that is there for tomorrow's test. So that is my goal. Given this, the problem statement, the breakdown of the problem statement is that, say for all the uh, I, as an app, might have some data about the student, right? So I still have to explore all the areas that I might have gotten better at since last solving that topic, right? So through the lectures or all the offline things that I've done outside the app, say, and I still have to explore all the new topics that are being taught right now, and unknown to the app because I don't have the data. All of these I need to explore and exploit the strengths of the student and quickly finish those, so that again I get back time to invest on things in my backlog. So that this whole thing, the explore exploit, I use these terms because these will naturally lend themselves to a reinforcement learning kind of a formulation, where the test will adaptively choose the next most uh, challenging question, which is also nearly solvable by me. And then that is how the levels keep increasing and my performance keeps improving as a student. So that is the gist of the adaptive test part. There is more nuance in the sense of how we use knowledge graph to solve this. And like I was saying in the original slide of assessment and learning, once we have assessed, we want to improve this particular topic for the student. And once we identify, say, the weaknesses at the lowest level of granularity, we can actually show the students one of the items which they might be better suited to learning from. So, and then we also, because we are a coherent app which is also in synergy with what is happening offline, we already know if, let's say, the lecture of this particular topic has already happened offline, and if a lecture happened, we want to go into a practice or a revision mode, or unless the attendance of the student is not there uh, in the class. So otherwise we would want to show, say, a recorded video of that lecture. And so yeah, based on this, basically there will be typically three modes of learning that the student could have once a weak area is identified. So if the student has already gone through the lecture, maybe it is a practice or something that I need to improve on this particular subject, that is given I have enough time. Otherwise, if there is an exam tomorrow or some such scenario, it would be revision that I need to be doing, and then the learning content would be something like a flashcard or a mind map or something like that. And yeah, so based on this, different kinds of content is shown to the students. And actually, again, creating some of this content also through LLMs is part of what we are working on. And so the content management part, so here initially when we talked about diagnosing the students skills, we talked about both curricular and non-curricular items, right? So say something like uh, reading comprehension is a extracurricular or non-curricular skill which is acquired before the student join Allen, say, right? And in the graph that I'm showing here, there are different kinds of nodes represented in different colors. And here in the green color, we are representing skills. Say reading comprehension is a skill I could acquire by the knowledge node English, which is in blue color. And uh, the knowledge node might have again sub nodes which are topics within that subject. In this case, the knowledge node is a subject, and each of those skills could directly map to a knowledge node in the knowledge graph. And so we see that the green color link which says acquired, it is small, maybe people can't read, but basically it says reading comprehension is a skill that could be acquired by learning English. So that is each skill could be mapped to a knowledge node. And then within that, there are those sky blue lines which will indicate the hierarchy of what that subject contains in terms of topics. So similarly, for a curriculum based node, mathematical aptitude is a skill that I will develop by learning mathematics. And mathematics is further divided into bunch of topics, which is basic maths, limits and vectors and trigonometry in this slide. And they are also interlinked among themselves, in the sense that if I want to get better at, say, trigonometry, I should know basic maths. And if I want to get better at vectors, I should know both basic maths and some trigonometry because of cos thetas and so on. And all of this information is tagged and present in the knowledge graph using the orange links that we have here. So once we have this, we have a sequence of what to study, right? So sequence starting, how to start or where to start, or and say once I have this knowledge graph created and all learning content and tests tagged at each node, basically I can assess each student's skills at different different nodes, right? So for example, I can have something like this, which is still not at a student, which is at a student level. So let's say I identified that, say, block A is a weak area of a particular student. Then all the things that are dependent on block A, right? So B, C, and D, B, C, D, and E, they will not be in a state where the student can understand it because the basic is weak. So in these kind of cases, we can focus more time on understanding A. Otherwise, uh, we can in parallel start the other blocks which are not dependent on block A, or we can say deprioritize block A or spend more time on block A depending on uh, yeah, how important it is, and how proficient the student is in each of these blocks, and so on. So basically, this helps us organize the uh, learning journey of a student uniquely, and basically the combination of strengths. And there is also the potential, right? So given that A is a weak point of the student, so if the student has aptitude in block A, uh, and if the student is able to learn block A really quickly, then that also unlocks B, C, D, and E for the student. And then it uh, it can be high scoring for the student, right? So based on this, again, block A will probably have more importance, and we can recognize that block A is more important because we've already organized our course into this kind of a knowledge graph which has prerequisite links. So all of this comes into our time management piece, which is personalized and based on which we have a unique learning journey for each student. And yeah, through the adaptive part, whose goal is to actually uh, make the student learn as much as possible with as limited uh, time, within the as limited time as possible. We can even say theoretically have some guarantees on what uh, on the time that the student could be spending to learn a particular syllabus item. So overall it ties up into something like this. So initially when the students join us, and continuously after that, the bottom picture is what I'm talking about, where we want to identify all diagnose all the strengths and weaknesses of the student, uh, and map them onto so this is what I'm talking about in the bottom part image, where each student's mind map is sort of uh, understood by our diagnosis, and then we map it to onto the knowledge graph, which is on the left side bottom. And once we have the strengths map, each skill mapped onto the knowledge graph, we know through the knowledge graph a really detailed small part that the student needs to learn or needs to practice. So that goes into the middle tutoring system part, which will do explore and exploit and say which one is the strength, which one needs improvement. And based on this, if you see, there are different arms that are in the tutoring system part, where each one is recommended by a content recommender. Which particular content or learning content should I show the student is coming from the learning recommender, which is at a individual content level. And then through the sequence of these learning contents and assessment items that we show the student, we actually progress the student uh, through the syllabus. And is there no student input in this? There is in the goal and the student params part there. So in the student params, we would be inferring things like what is the memory retention of the student, when should I be refreshing things that I've already made sure that the student already knows. All of those will be in the student params. And the goal, the temporary goal that I talked about, that say I have an exam today, exam tomorrow, and I have 1 hour to study, that would be going into the goal. Or I have 1 hour to practice and I want to learn this particular topic, that will be in the goal part. And finally, will, with the help of these personalized uh, uh, pedagogy, and then the bot actually explaining interactively and co-solving with the student, we would try to achieve mastery of the whole syllabus for each student in their own unique learning journey way. So with this, I'll end this presentation and stop for questions. Got it. So are there any questions from the viewers? You can post it in the chat. Got it. So uh, we have a couple of giveaway questions. Uh, so the answer for this question, so the top answers in for these questions would get a uh, course as a gift. So let me start by asking the first question. So yeah, so for the adaptive quiz that we talked about, other than the multi-arm bandit one that we showed in the presentation, which model would you think would be a great fit for the adaptive personalized test generation? Please answer in the comments. So the QR code that is shown uh, on the screen now is where you can go and answer this question. Got it. I have a question which reads, how can personalization and GenAI bots transform the educational landscape to better cater to individual student needs and learning styles, right? So I think a bunch of things that we've talked about in the presentation, right? So say if the student's learning style is say mostly visual or through short videos, or say if it is for this particular topic, I'd prefer learning through images, or I want to know the practical application first or something like that. All of those things could be interactively got from GenAI bots, right? So that is one, and the major advantage is in the personalization, which actually has proper time management, right? So say I have a lot of backlog, and uh, if I have to basically uh, organize my course with the knowledge that which is a foundational course, and how much weightage that does this course have, this topic have in the final exam, and based on that prioritize, and how well am I progressing compared to say others in the class. So based on that, if I can prioritize that information, and that prioritization will be really helpful to the students. So that is roughly how personalization would help individual learning styles of a student. Don't you think AI bots brings down the user experience? So I think this is compared to interacting with an actual teacher, right? So that initially it will be it will definitely be not as good as uh, talking to a regular teacher from the get go, but it will be instantaneous. So basically, the problem that I was talking about while asking doubts, right? So if I say even have the doubt teacher available in my classroom, I got the doubt while I'm solving it at my home, right? So there's still that barrier that I have to go back to the teacher, wait in line or something to ask my doubt, and or ask on say WhatsApp or something, and then wait for the teacher to reply. That time could be effectively utilized by interacting with the bot. And let's say if it is a question that is common and is asked by multiple students and already answered by the same teacher multiple times, taking from that and making that in an interactive way, and say if I want to explain it with say a diagram or something, and an annotated version of the diagram, those are all the things that bots can do right now. And then uh, it can be interactive, so basically it doesn't need the single teacher's time or something. So that way it will be better. Basically, it has its strengths, and uh, it initially, at least, it won't be as good as, say, interacting with a teacher. So yeah, the question was, I think, yeah, don't you think AI bots bring down the user experience? Got it. Okay, I got another question. How is this tuned using existing user data? Yes, the personalization algorithms are all tuned based on existing user data. So our estimate of uh, how much proficiency is needed to solve a particular question, all of those are tuned using existing user data. Got it. Then time for the second question uh, for the giveaway. And yeah, so what do you think will be the biggest challenge in personalizing education for each student? Also, please keep the questions coming so that we can. I see some suggestions from Tarun about using GeoGebra and Microsoft Math Solver. Thanks for that. Got it. So, repeating the second question again for the giveaway. So, what do you think is the biggest challenge in personalizing education for each student? Okay, if there are no further questions, I'd like to thank everybody for joining and have a nice rest of the evening.